And oh, perfect. Thank you. And luckily was asked by a childhood friend to give a presentation to the Lake Fellowship back in December. I was looking at my notes, and I'm really excited to share some of that as well as some updated information with you. So as I said, grew up in Minnesota. I went to Minnetonka High School, and then I did a little bit of research while I was in high school, which really got my feet wet. And then I went to Stanford for my bachelor's in bioengineering. And while I was there, I really discovered that I am incredibly interested in science, but also in how science can improve health. So I figured that the best next step would be to pursue a dual MD and PhD degree, where I could learn both how to advance the frontiers of science with my own research and also how to treat people as a physician. So I started my MD PhD in 2016. Hard to believe that it was that long ago. And it's been a total blast so far. So I've done the first 2 years of med school and then 3 years of my PhD. I'll wrap up my PhD next year, and then I'll finish up med school. And this is a very long training path. So after that, I will do residency and fellowship, and this will take many, many more years. But eventually, my hope is to run my own research lab and see patients as an MD PhD. And in particular, I'm interested in vaccine development. So the COVID crisis has been a time that I have found a way to use what I know about science to help inform everybody who's interested in this topic, which has been a nice way to feel like I'm being useful to the broader public. So I've done a little bit in vaccine education since the winter. I started an initiative where Stanford MD and PhD students were paid for their time to use social media as a platform to engage people. I've created a lot of vaccine education materials and distributed them through the Stanford Healthcare Network, which has been very fun. I've gotten a chance to speak on podcasts and panels. I've trained local health services like free clinics and EMS, and I've given vaccine education seminars like this one. And all of these things have been incredibly fun, and I think have really cemented my desire to continue to do science education as well as actually doing science in the lab day to day. So I'll plan to give an overview of COVID-19 vaccines. I think I'm shooting probably for about the middle of this time, and then we'll open up the rest of the time for Q&A. I do want to say, if there's a question that comes up, please feel free to stop me, because often it's easier to address a question in the moment than at the end. So don't be shy to interrupt. Great. So to start with a 10,000-foot view, how do vaccines work in general? The premise is that you take a killed or weakened form of a pathogen, so either a bacteria or a virus, and you inject it into your body. And then your immune cells, both the innate and adaptive parts of your immune system, learn the molecular signature of that pathogen and store that information in a memory response, so that when you see the pathogen a second time, you can respond both more quickly and more strongly. So the players, in terms of which cells are taking action here, are cells in your innate immune system, which are showing the pathogen to cells in your adaptive immune system, which is the side of your immune system that learns what the pathogen looks like. So on the adaptive side, you have T cells and B cells. And what T cells can do is they're the hand-to-hand combat soldiers, if you will. They can directly recognize if a cell has been infected by a virus and kill that cell to prevent the cell from creating more viruses and infecting other cells. My personal favorite, B cells, are the long-range soldiers, if you will. They create proteins called antibodies that circulate through your bloodstream and are able to bind to viruses and stop viruses from getting inside cells at all. And I'm going to talk a lot about how B cells are responsible for the immunity that we see from COVID-19 vaccines because of these proteins called antibodies. And then, not to be forgotten, because of the critical role they play for memory, is that both the B cells and the T cells can store the information about what a pathogen looked like in specialized versions called memory cells. And these can live for years, decades, and even for some pathogens up to someone's entire lifetime, which is why for some of the vaccines you get, you only need to get the vaccine as a child, and then you're immune for the rest of your life. So that, at a high level, is how all vaccines work. And a brief review on what an antibody is, if some of you are not protein scientists like me. An antibody is just a protein that's shaped like a Y, and the little tips of the antibody can recognize the virus. So for the COVID-19 vaccines, your body's creating these Y-shaped molecules where the tips are ones that can bind to the spike protein on the surface of the virus and stop it from getting into cells. Cool, and that's what I just said. Great. So now what is the point of vaccination? In this diagram, what I'm trying to show is that the first time you're exposed to a pathogen, it takes your cells a little bit longer to ramp up, and the overall immune response measured by either number of T cells that are reactive to that bug or the number of antibodies that are floating around is less than if you've seen the pathogen before. And that makes sense because your body wants to evolve so that once it knows that something is a threat, it can respond more strongly the second time. So vaccine developers have co-opted this and used it to create vaccines, which are not going to make you sick, so that the second time when you encounter the virus for real, you have a faster immune response and a larger immune response. You could even expand this with vaccines that have a booster. So in this case, you can imagine the primary immune response is what happens when you get your first shot. And if it's a vaccine where there's a second shot, when you get your booster, you're going to have a slightly faster and slightly larger response. And then when you see the actual pathogen, it's going to be even faster and even stronger. So the purpose of a boost is to increase both the speed and the intensity of the immune response. And for some of the COVID-19 vaccines, there's a boost for that reason. So there are tons of ways to make vaccines, and the science behind these different modalities can get pretty complex. But I want everybody on the call to have a pretty firm understanding of what both nucleic acid vaccines are and how they work, and what virally vectored vaccines are and how they work. The reason I picked these is that they're the current stars of the show for COVID-19 vaccinations in the United States, where the Pfizer BioNTech vaccine and the Moderna vaccine are nucleic acids, and the J&J vaccine is a viral vectored vaccine. Thinking about how vaccine development has worked in the past, it's important to note that it's very difficult to make vaccines quickly, and the overall chances of success from when you start trying to make a vaccine product to when you finish is 6%, which makes the incredible achievement of not one, but multiple effective COVID vaccines really, really a feat, a scientific feat. And prior to the COVID vaccines, the quickest turnaround ever was for a flu vaccine in 2009. And even then, it took 6 months for the vaccine to be ready for distribution and use. And instead of having to create a vaccine for a whole new virus, which is what we've done for COVID-19, in that case, they just needed to switch the strain. So I say that to demonstrate how much of really like a global team effort it was to get these vaccines. And it was impressive, even to the scientific community, just how well they worked. So how was it possible then to make this vaccine for a completely new virus in 11 months? A few things. One was the infectious agent was identified very quickly. So researchers in China were able to identify what that virus was, and then they made the sequence of the virus, so the genetic material that makes it up, publicly available within 4 days of identifying it, which made it really easy for scientists around the world to all jump on it and start making potential solutions, which is exactly what happened. And then another piece of information that scientists really care about when thinking about vaccines is the actual structure of what the proteins on the surface of the virus look like, because those are the handles that the antibodies are going to be binding to. And so the structure of the main coronavirus spike protein was also solved in record time. And these achievements really set the stage for vaccine development to take off. Now, a question I get a lot from people is, how did this vaccine get approved for emergency use so fast when normally it takes a vaccine 5 years to be approved? This is an awesome question. What I like to highlight are two main things. One is there were billions and billions of dollars invested into the development of coronavirus vaccines, which enabled each portion of the vaccine development and approval pathway to happen at an unprecedented speed. And that's simply because there were more resources. They had more money to make more vaccine doses and to run their clinical trials, which is great. It was absolutely the right call for that many financial resources to be put into this problem. The second thing is that parts of the process that normally happened sequentially were able to happen in parallel. And that's possible because there was more finances available. A good example that I like to tell people for how to understand how this actually plays out is normally you would never make hundreds of millions of doses of a vaccine until you already knew that it worked. And so what you would do is you would run a trial for 3, 6 months, a year. Then you would say, okay, good, my vaccine works. And then you would spend about a year to 2 years figuring out how to make your vaccine in the scale of hundreds of millions of doses. And so total, that process is going to take about 3 to 4 years. But in this case, there was the finances available for each of the vaccine companies to make hundreds of millions of doses of vaccine at the same time that they were testing to see if they worked. So that if they did work, they could immediately start vaccinating millions of people, which is what happened with the mRNA vaccines. So that's how it was possible to get this done so quickly. It wasn't that certain steps were skipped, which is very important when thinking about making people feel good about how safe these vaccines are. So how do the mRNA vaccines actually work? It's amazingly cool. The way that all proteins are encoded in viruses and in humans is that there's DNA, which is one form of a genetic code. It gets changed into an intermediate genetic code called RNA. And then RNA gets translated into protein. And proteins are these molecules that make up your entire body. They help cells do all kinds of important things. And in the case of SARS-2, they help the virus get inside cells. So the M in front of mRNA stands for messenger. And it's because these molecules are messengers that tell the cell which proteins to make. So what protein are we making for these vaccines? Here is our friend or enemy, really, SARS-CoV-2. And what you can see from looking at this, which is an actual image of the virus at a very, very close scale, is that there's these little spikes that are sticking out of the virus surface. And those are the protein that is the target of all of the approved vaccines. And the reason we want to target that protein is that if you have antibodies floating through your body, they can bind to this protein because it's on the outside of the virus and it's available for binding. So that's good, because if you target a protein that's inside the virus, it would be hard for your antibodies to neutralize it. Secondly, this protein is what SARS-2 actually uses to get into cells. So if we block it, it won't be able to get in and infect us. And I've broken that down a little bit more in this diagram. So again, the circle is the virus. These little thorn-looking things are the SARS-CoV-2 spike protein. And the way it gets into your cells is it binds to this receptor called ACE2 and then gets cleaved by this other protein and is able to actually fuse the contents of the virus with your cell, which is bad news if you're trying to not get infected. What you can do, though, is if you, either by getting infected with coronavirus before or by receiving a vaccine, have antibodies that bind to the spike, they physically block the spike from binding to the receptor. And so instead of being able to stick to your cells and then get inside, the viruses are just floating around through your blood, completely covered with antibodies, and they're eventually filtered out the way that other pathogens are. And so this is great because you can imagine if you have enough antibodies around, the viruses can't fuse with your cells and it's impossible for a productive infection to be established. So as I put in red over here, the basic goal of vaccine is to make antibodies that block the process of the virus being able to get inside of your cells. Here's the star of the show for those of you who want to know in detail what it looks like. This is Spike, and here's a picture of what it would look like decorating the surface of the SARS-2 virus. Now, one of the missing pieces here is how do we get our own cells to make Spike so that we can learn how to respond to Spike with an antibody? This is where the science becomes incredibly cool. So we take this mRNA molecule, which remember is going to encode for the spike protein, and we stick it inside these lipid nanoparticles. Now, the reason you need to do this is that your cells are all made of lipids, because it's very important for your cells to keep the liquid contents that are inside away from the liquid contents that are outside. So the best way to do that is to create essentially an oil layer where water can't go through easily. The problem is lots of other things can't go through easily, which is great for your cells not letting in random garbage, but is bad for drug development, because if we give you an mRNA that's naked, it probably won't be able to get into any of your cells because it's positively charged and it can't go through the cell membrane. So what scientists spent a long time doing, even before the coronavirus pandemic, was developing a strategy where you can take this mRNA, put it inside a little fat bubble, and then the fat bubble can fuse with your cells because fat likes to mix with fat. And so when you actually receive the vaccine, what you're getting is an mRNA, if you've gotten an mRNA vaccine, is an mRNA that encodes for spike hidden inside a little fat bubble. And then this fat bubble finds a cell, probably very close to where you got the injection, fuses with the cell, delivers this mRNA molecule, and then you already have these proteins in every cell called ribosomes, which turn this molecule into the SARS-CoV-2 spike protein. And then the SARS-CoV-2 spike protein sticks out of your cell, and your own immune cells are able to recognize that spike protein and respond and learn what spike looks like, so that when you see spike in the context of the virus, you have molecules that can neutralize it. So one of the important things to know is that this mRNA that's being delivered to your cells is naturally degraded in a few days. So it's not sticking around forever. You won't have this molecule for longer than probably about 72 hours. And another important point is that the vaccines can't give you COVID-19 because the only component of SARS-CoV-2 that they are delivering is the instructions to make spike. And a virus actually needs, I think for SARS-CoV-2, over a dozen proteins to create a whole virus that can actually continue infecting cells. So all that you're putting into your cells is this one little component, and you could never get a productive infection from just having this component of the virus, which is good because that's a concern that some people have about the vaccines. All right, so what is in these mRNA vaccines? mRNA, which we now know how that works, that's the star of the show. There's also these lipids that make that fat bubble that helps it get into your cells. There's salts, which keep it at the right pH for your body and stable, which is really important. And then there's sugar, which helps with the freezing and thawing process. So it keeps these little fat bubbles from falling apart when the vaccine product is stored at a frozen temperature and then thawed. And there's no preservatives or any other ingredients, which is important because a lot of vaccine hesitancy is driven around certain preservatives that were included in other vaccines. So the researchers who developed these vaccines just went ahead and didn't include any of those preservatives to try to avoid those concerns, which was a nice step that they took. All right, what are the differences? Honestly, as a scientist, there's not really important differences between the Pfizer and the Moderna vaccines. They are both creating the exact same spike protein, and there's only minor differences in the composition of the little fat bubbles that get into your cells. The storage conditions are slightly different, but the efficacy numbers are almost identical, as we'll go into. Oh, and also, as some of you know who have gotten your vaccines, the boost timing is different by 1 week. But again, not a significant difference, and they both work equally well. All right, so how safe and effective are these vaccines, and who can have them? They work incredibly well. So these were the numbers that came out of the clinical trial, which is 95 and 94% effective at preventing symptomatic COVID-19. Now, for a while, we weren't sure how each of these vaccines prevented asymptomatic COVID-19, which is also really important because, as some of you might know, you can transmit COVID without knowing that you're infected. So updated data that we've gotten over the course of the last few months shows us that these vaccines are roughly this effective at preventing asymptomatic infection with COVID-19 as well, which is really important. So the numbers I've seen most recently are somewhere around 90% prevention of both asymptomatic and symptomatic COVID-19, which is critical for helping reduce transmission as well as helping prevent people from getting very sick. These were the numbers of people that were in each trial. And by now, as you may know from watching vaccine trackers, each of these vaccines has now been in almost probably northwards of 50 million people in the United States so far. And what was nice about the way that they designed the trials was they purposefully included people of different ages, different sexes, races, in order to try to understand whether or not the vaccine worked equally well in all of those people. And the answer was they didn't find any group where the vaccine didn't work just as well as any other group, which is really important because this vaccine, as we know, is going to have to go into people all over the country. The exception to this is younger people and pregnant people. So since the initial trials that were happening back in the fall and winter, they've started trials in both pregnant individuals and in pediatric patients. And an exciting update to this is that, as I saw, and maybe some of you also might have seen, the Pfizer vaccine was actually expanded for emergency use authorization in children as young as 12 today. So go and tell your family, your friends, your kiddos that you like and that you don't like, because everyone deserves to be saved, that they can get the Pfizer vaccine, I think probably starting today or tomorrow, which is really, really good news. And the cool thing about this data is that the vaccines actually look even better in kids than they do in adults. So if you look at the clinical trial data for the Pfizer vaccine, it was 100% effective in preventing infections in this age group over the course of the trial, which was a very, very, that's a great number that you really like to see as a scientist. And more information is coming out on the safety of these vaccines in pregnant people. I'll have a slide on this later, but it's all good news. So here's some of my favorite graphs of all time as somebody who works on vaccines for a living. These are the data that was submitted to the FDA when they were trying to apply for emergency use authorization. So they had to go with their big packet of data and ask the FDA, can we give these vaccines to people? And this was the most compelling and central piece of data, which is that they tracked symptomatic COVID-19 infections in both people who got a placebo shot and people who got the real shot. So the way these trials were designed, they didn't want people to know if they had actually gotten the vaccine or not, because that might change how people behave and then throw off the results. So you didn't know whether you got a real vaccine or you just got a shot that had like salt water in it, which is a nice and important way to design your trial. So you can see here in the placebo group, the incidence of symptomatic COVID-19 infections is going way up. And at the same time, in the group of people who got the vaccine, even after the first dose, you see a dramatic plateau. And then after the second dose, there's almost no additional growth in this population at all. And so when people say the vaccines are 95% effective, what they're doing is they're comparing the total number of cases in the group that didn't get vaccinated to the total number of cases in the group that did get vaccinated. And they're asking, how many percent did we avoid by giving these people this vaccine? That's how they got the 95 and the 94% numbers. And here's the exact same graph for the Pfizer vaccine, again, with very similar efficacy. You can see just a dramatic plateau where you stop really seeing new infections in the vaccinated folks, except for a very few, which is really, really good news. And on the safety front, something that's really important to talk about is that no serious long-term side effects have been associated with either of the mRNA vaccines in either trial. And that was over 70,000 people. And now they've been in 100, between the two of them, over 100 million people with no serious long-term side effects, which is great. So now, what about the J&J vaccine? I think it's interesting that because there was so much attention paid to the newness of the mRNA vaccine, people don't seem to also understand that the J&J vaccine is also a fundamentally new technology, which is instead of using these little fat bubbles to deliver the mRNA, you're using something called an adenovirus, which is a different kind of virus that doesn't make you sick to deliver the mRNA. So here's a little diagram showing how that works. Here's our friend, the genetic material that encodes spike. And sorry, I think I misspoke 20 seconds ago. In the case of the J&J vaccine, it's DNA that's being delivered, not RNA, but it creates the same spike protein. So in this case, you give DNA into the cells, the DNA becomes RNA, and the RNA becomes the spike protein. So that genetic material is encased inside another virus called an adenovirus that doesn't make you sick. And the reason that they're using the adenovirus is to get this piece of DNA inside cells. So it's the same purpose as the fat bubbles for the mRNA, but in this case, it's a virus that doesn't make you sick that's able to deliver the DNA encoding spike into your cells. And then from there, the same process happens, which is that your own cells make the spike, put it on the cell surface, and then your immune system learns what that looks like so that when you get infected or potentially exposed to the real coronavirus, you have antibodies that can bind to it and stop it from getting in. So how does the J&J vaccine differ from the mRNA vaccines? Because as we've discussed, it's mostly the same, which is delivery of genetic material, spike is made, and it protects you. One thing that I mentioned earlier is it's delivering double-stranded DNA instead of mRNA, but both make the same spike protein. So the final product is the same. The J&J vaccine also only needs one shot, which has made it an incredibly popular choice in the United States. So if you look at preference surveys for people who are offered multiple vaccines, most people are choosing the J&J vaccine because of the additional convenience of not having to return for a second shot. The other thing that's great about the J&J vaccine is that the fat bubbles are kind of fragile, so you need to store them at very, very cold temperatures. The adenovirus can be stored in the fridge for 3 months. And so when you're thinking about a global supply chain or giving vaccines in low resource settings, the Janssen vaccine has a definite advantage over the mRNA vaccines. So let's talk about efficacy. These numbers, 72% effective and 66% effective worldwide, might look lower than the 94% and 95% that I just showed for the mRNA vaccines. But I think there's some important caveats that I want to discuss. First, the J&J vaccine caused 100% prevention of hospitalization and death. So when you're looking at the outcomes that we really care the most about, which is preventing people from going to the hospital and dying, the vaccines are equally effective. That is, the J&J vaccine is equally good at preventing people from being hospitalized and dying. The second thing is that when the mRNA vaccines were being tested, none of the more transmissible variants were in play. Whereas when the J&J vaccine was being tested, a lot of these variants were now in the mix. And there's some data to suggest that the variants might make vaccines slightly less effective, which could be responsible for this difference in preventing symptomatic COVID-19. So I put this little apple and orange down here just to say that it's not necessarily fair to compare the efficacy numbers between the two trials because they were being trialed in different populations where different viruses were spreading. And most importantly, they're both 100% effective at preventing hospitalization and death, which is what we really, really care about. And then as I talked about earlier, the single shot and the ability to stay at refrigerator rather than freezer temperatures is going to make a huge difference in who can get this vaccine around the world. Great. So a question that I've been fielding a lot recently is, what happened with the J&J? What about the recent pause? Should I be worried if I got the J&J vaccine, or should I avoid it in the future? Tell my family and friends to avoid it. So let me lay out what happened. Over 7 million doses of the J&J vaccine had been given in the United States prior to when this pause happened, which was in the middle of April. And at the time that they initiated the pause, they were getting very, very rare reports of something called thrombocytopenia syndrome, which is where you have blood clots and low platelets. And so this was not something that they had seen in the clinical trials because of how rare it was. So if you look at the rate here, 15 and 7 million, and their trials were done in probably about 40,000 people, you're simply not going to see any cases because it's just too rare. So they saw this in 15 people, and they paused the delivery of the vaccine to be able to get a bunch of scientists together to verify all the reports, to make sure that they were looking at the data very carefully before they made a decision about, should we continue to give J&J or should we hold off on J&J because we have these other vaccines? And what they decided at the end of the day was, number one, it's an extremely, extremely rare side effect. And so it's difficult to even know, like, they think that it's due to the vaccine, but it's also hard to say because that incidence is not that much higher than the incidence in the random population. So the first thing I think as a take-home message is it's a very, very rare side effect. The second thing that the CDC and FDA agreed upon is that the risk of blood clots due to the vaccine was at least 100 or 1,000 times less than the risk of blood clots from actually getting COVID-19, which causes many people to go into something called a hypercoagulable state, which can cause blood clots, which can lead to nasty things like strokes and problems where you have blood clots in your lungs. So looking at those numbers side by side, they said these vaccines offer way more of a benefit than they pose a risk. And so taking all of that information together, they decided to release the hold on the vaccines and continue vaccinations. The only thing that's changed is there's now a new warning on the vaccine. So the vaccine just says, in women 18 to 59, which were the only people that this side effect happened, there's and they say like, I think it's 0.00006% risk of the development of blood clots. And then they advise people that, you should look for a severe headache after the vaccine as a potential sign. And then if you do have a severe headache, you can go into the hospital and get treated. And there's good treatments if someone does have this condition. So the other thing that I wanted to mention, because I've had people say, I got J&J like 3 months ago, should I just be like on my tiptoes, like worrying that I might have a clot? And the answer is no. So in the folks that did get this side effect, all of the cases happened between 6 and 15 days after vaccination. So that suggests that it's some kind of response to when they received the shot, and that if you got the J&J vaccine, you should, and you're past 2 weeks after getting your vaccine, you should feel very good about the fact that now, A, you're protected from the coronavirus, and B, you're not going to get this very weird and scary side effect. So wanted to put in a note because that was a recent development on the vaccine front. And I thought, as a sidebar, I thought that this would really hurt uptake of the J&J vaccine, because it seems like if you pause something and then restart it, people might be wary. And actually, I was wrong. So by the numbers, it still looks like after they restarted the Janssen vaccine, that people are still preferring the Janssen vaccine over the mRNA vaccines, probably due to a combination of the convenience and also the fact that a lot of emphasis was placed on how new the mRNA vaccines were. So despite the fact that the J&J vaccine is also new, I think that that's not playing as heavily in people's minds, which is just very interesting. It goes to show that you can't always predict what people are going to want to do. So more about vaccine safety for people who are wondering about this. What about long-term side effects? So I used to get this question a lot, especially in December and January when some of us were getting our vaccines and we really didn't have any more than 6 months of safety data. The good news is that if you look backwards at all the vaccines that have ever been licensed, any safety effects that came up in clinical trials or in surveillance all came up before the 6-month mark, which is to say that the likelihood that we have a sneaky long-term safety risk is just very low based on every other vaccine that has ever been approved. So that's something that gave me a lot of comfort as a scientist. Second, and this goes exactly in line with what happened with J&J, is you would expect side effects to be due to the vaccine components themselves. So that would be a few days after giving it, or when the immune response peaks, which is a few weeks after giving it. And so both of those critical time periods are included within the trial. And indeed, for J&J, even though it was extremely, extremely rare, it did happen in that second window where you're expecting the immune response to peak. So the likelihood that there's something else that happens way in the future doesn't line up with our understanding of how the vaccines work. And then part 3, trials were big enough that even rare side effects are likely to have been picked up. So this is true. I think now I would say I'd add an asterisk to this to say, obviously, if your side effect is 1 in a million, you may not find it in a trial of hundreds of thousands, which is what we saw happening with the J&J vaccine. Great. So one thing I want to specifically address is infertility concerns. This was something that I heard a lot of, especially earlier this spring. And it was due to 2 viral sources of misinformation, unfortunately, that made their way around the internet and especially made their way around the nursing community, which is very tough because a lot of people rely on nurses for high quality health information. But this circulated actually rather successfully within those circles, which was tough. The key takeaway here is that there's no evidence that any COVID vaccine affects fertility. People who are both in the clinical trials and now tens of thousands of people who have been vaccinated have gone on to have pregnancies that have been successful with no unexpected issues. And the nice thing, or maybe a silver lining to having picked up the J&J side effect, is that we now know that our vaccine reporting system is robust enough that we would pick something up if it was 1 in a million. And so we can say with relative certainty that there's not risk to fertility because we would have picked it up. We have a very sensitive reporting system. Great. One thing I do want to emphasize too is that for those of you who haven't been vaccinated yet, or if you were vaccinated, you might know that you should expect side effects. So side effects are an exhibition of how your immune system is responding to the vaccine. If you didn't have strong side effects, it doesn't mean the vaccine didn't work. There's actually no correlation between the degree of side effects and the degree of efficacy. But there's no need to worry if you had side effects from the vaccines because it's actually expected. And so these are some of the numbers that show how frequent these side effects were in the clinical trials, which is that most people had injection site pain, fatigue, and headache, over half of people who got the mRNA vaccines. But luckily, these side effects should clear up completely within 2 to 3 days, and your immunity should last for a lot longer. All right, so I wanted to briefly comment on the new CDC guidelines. So you may have seen the CDC has been very busy putting out lots of new guidance now that a bunch of us are vaccinated. And I like this a lot. I think it's helpful for them to show specific examples. What I wanted to add here is that I think specific examples are good, but you also want to give people an understanding of what the underlying science is so that they can make decisions when the specific example that is in their life isn't on the little CDC fact sheet. So what I want to add is that the reason that these recommendations are what they are is that vaccinated people are much less likely to be infected. So like if I go to a party and I'm vaccinated and my counterpart is not, the likelihood that one of us is unknowingly infected with COVID when we arrive is dramatically lower for me. So that's one of the sides of why the guidelines are different for vaccinated people, is that I'm less likely to have COVID without knowing it as a vaccinated person. Second, even if I do have COVID, I'm less likely to spread it to other people because there's been studies showing that vaccinated people, even the very, very few that do actually get infected with COVID, don't shed virus to others at as high of a level as unvaccinated people. So there's 2 ways that vaccinated people are protecting other people. 1, by being less likely to have COVID at baseline, and 2, being less likely to spread COVID even if they do have it. Then on the second point, this is the other side. So like benefit of being vaccinated, number 1, is that you're reducing risk to other people. Benefit of being vaccinated 2 is that if somebody else rolls up to the gathering who has COVID, you're much less likely to get it, even if you're exposed to someone who's infected. And that's, as we talked about, because you have all these friendly antibodies floating around ready to save you. And the third thing is that the key drivers of transmission risk are distance away from someone, masking, and ventilation. And that's why these guidelines are really centered around managing group size, masking, and outdoors versus indoors, because outdoors you have wind. It's much less likely for viral particles to build up into space. Distance, once you get 6 feet away, it's about 90% decrease in the amount of infectious virus that's able to reach someone. And even at 3 feet, you're at about 70% reduction in the amount of virus that can like essentially go through the air between you and someone else. And obviously masking is like a real barrier to viral particles being able to go from one person to another. Something that I want to emphasize is that people were very worried about surface transmission early on in the pandemic. And unfortunately, it's led to a lot of what I would call hygiene theater, which is like either places or companies or restaurants, like spraying everything down with bleach, which unfortunately, as we know now, like surfaces are not the driver of COVID-19 transmission. So a lot of times those things are mostly employed to make people feel better rather than actually curbing ventilation. So, you know, if you're a restaurant owner, it really doesn't matter if you're bleaching the tables. It matters much, much more if the tables are actually far apart from each other, if they're outside, and if you have fans or windows open. So something to keep in mind when you see a company or a place doing a lot of focus on like spraying things and bleach and surfaces, The science now tells us that that's not really how infections are spreading, except in very, very, very rare cases. Most of the time, it's virus going directly from one person into the air through these small droplets to another person. And then here I just added the other half of this, which is the guidelines for indoor. And as you'll see, based on what I just said, indoor is more dangerous for everyone because there's less ventilation. So now all even vaccinated folks are recommended to be wearing masks if they're in a public setting, which is what's in here. And unvaccinated folks, even with a mask, are less safe in these indoor settings that have few people and much less safe in these indoor settings that have lots of people. So something to keep in mind, and hopefully that jives with what we know about transmission that I just explained. Great. So my last few slides are, this is the current state of vaccination in the United States. So overall, we have about 46% of the country that's received at least one vaccine dose, which is honestly incredibly impressive, especially considering how few people have been able to get vaccines in other parts of the world, especially as you probably have seen in the news, India is getting very ravaged by coronavirus right now with devastating consequences. One of the things that's really important to think about is this question of herd immunity. So early on in the pandemic, what Fauci and others were emphasizing is that when 70% of us get our vaccines, then we'll achieve herd immunity, and then spread will be more difficult. And that initial hypothesis has gotten a little bit more complex now that we know about things like variants that are easier to transmit. And given the increased transmission of these new variants, an updated number that I've heard from Fauci and others is about 80% of a community would need to be vaccinated in order to prevent community spread. The problem is that current polling shows that 30% of Americans are reluctant to be vaccinated. And so obviously, the math doesn't really add up there. We would need that number of people who are unwilling to be vaccinated to drop under 20% to get to where we need for herd immunity, which is really going to be the ongoing battle. And I think that there's a lot of complex reasons behind why folks are reluctant. Hopefully, some of that will chip away, especially as vaccinated people are able to return to doing things that they enjoy. So to touch a little bit on what Karen was talking about how do you convince people to get vaccinated if it's something that they're scared about? What the science that I've looked at has shown is that the most important things to focus on are personal anecdotes and things that are relevant to their life. So if you talk to someone and you say, we need 80% herd immunity, you have to do your part. People are not moved by that. Maybe some people are, but most people are like, that's not going to be what changes their mind. If you instead say, like, I'm so glad that I got vaccinated, I can now see my grandma without worrying about getting her infected with COVID, or I can now go and eat with my friends at an outdoor restaurant, and it's been amazing to feel like my life in one aspect is returning to normal. People respond extremely well to personal anecdotes about how vaccination has improved your life and thus how it could improve theirs. So keep that in mind. And then also knowing concrete facts, being able to legitimately answer their questions and concerns or to refer them to good resources. So yeah, keep that in mind when you're engaging with your contacts, and also know that most decision-making is driven by what one's immediate circle is doing. So you could be the person that is able to convince someone, both through your own behavior and what you're able to tell people, that really has sort of a ripple effect as more and more people decide to get vaccinated. So it's definitely worth the effort of those maybe slightly awkward conversations. Great. So the bottom line is the more people are vaccinated, the more infections and deaths due to COVID-19 will continue to drop. So here's just since the beginning of the pandemic, what the new case rates have looked like in the United States. And as you can see, we were on this high plateau for a very long time. And now we're starting to drop off this high plateau, which is good. And hopefully, as people continue to get vaccinated, we will be able to see this line continue to go down. So that is it. I'd like to stop and ask for questions, and hopefully I can answer anything that I wasn't able to address in the talk. Thank you all so much.
Well, thank you so much, Maria. I feel like I just got my booster shot, of this information. And it's amazing. Do we want to, do you need to have your slides up, or do we take them down so that we can kind of see each other? Those of us who are, if you are somebody who's here and still, eating dinner, or, needs to have your video off, that's fine. But if you want to kind of come back in, it's always nice to see your shining faces. So, yeah, I think questions that folks have.
Maria, this is Heidi. Thank you very much. I'm an RN. I actually work in neonatal unit in Minneapolis, but I'm doing giving COVID shots, Moderna shots on the side.
Oh my gosh.
Yes.
Real life hero.
Oh, well, you know what? It's really wonderful. I get chills when I do it. I'm so excited. So, but of course, people often ask me, and I do believe that the efficacy is the same, whether you have a dramatic response physically or you don't.
Mm-hmm.
But I still get that question. And also, when will we need a booster?
Yeah.
Those are the questions.
So I think you can definitely continue to confidently tell people that there's no relationship between side effects and efficacy.
Okay.
I think the best data for that is probably in the clinical trials themselves, where participants had like all ranges of responses from none to dramatic responses, and there wasn't a correlation between, who ended up having those very few breakthrough infections and who didn't. So that's good. You can strengthen your convictions about that.
Okay.
And on a booster, this is a hotly debated topic. So what it's looking like right now is that immunity is not waning super quickly, which is a good thing. So it seems like folks who got immunized back in December or January are still like roughly speaking not getting infected at the same rates that they were like 2 months after they were being vaccinated. But there's no crystal ball that is really helpful for looking at like when could we expect to see boosters. The people that I trust the most, just because they've worked on other vaccines, are thinking like 1 to 2 years. That's what they've been throwing out. And that's purely a guess based on how other coronaviruses act, what the deal is with the variants. But I think it could, I doubt that it's less than that. I doubt we will have to get boosters sooner than a year. It may be more than that. And one thing that I actually didn't get to touch on, which I'm glad you brought this up, is that a lot of concern has been focused on like, what about the variants? And will we need boosters for the sake of inoculating against the variants? So scientists are like watching this issue with more intensity and focus than I've ever seen. And so far, the story is that against every variant that we've tested, it looks like the serum from people who were immunized with the Pfizer and Moderna vaccines, which is the ones they've tested so far, I'm sure they'll get there with J&J. It looks like it'll still be protective against the variants that are circulating.
Good.
And so that's really good. As we know, like you have to test each variant, and new variants are going to continue to crop up, especially now that like other parts of the world are really sinking into very scary case increases. So scientists are watching. The current vaccines look like they're going to hold out for now, but there will certainly be the potential for an arms race where a variant emerges that isn't covered well by the current vaccines, and the vaccine producers are incredibly ready to just drop the new variant into a vaccine and distribute that quickly. So I know, for example, that like Pfizer is fully prepared to synthesize a new piece of mRNA and drop it into their existing platform and give boosters to everyone. And the nice thing is that the trials would not need to be repeated. So you'd need to do a small phase 1 safety trial, but they could be used immediately. So that's a good thing to keep in mind as like who's going to win the arms race. The nice thing is we have a lot of people who are thinking about this who are ready to deploy those vaccines immediately if we do have variant escape.
Oh, wonderful. Thank you very much.
Yeah, of course. And I think there's some questions in the chat. Is that right?
Yeah, I'm seeing Therese had a couple of wonderful questions. Therese, do you want, we're a small enough group. Do you want to just read those out loud?
Sure. You can hear me? I had to put my headphones on. My family is sort of noisy, but so I'm 69, my husband's 73. And thank you for answering the question. He feels his immune system isn't strong because he didn't react symptomatically to the virus. I mean, the vaccine. Okay, so that's good. My daughter-in-law is 41 and her husband is 38. Our son, we have two little kids, 9 and 7. And Dave had to get the vaccine. He's a jet pilot. He works for the Guard.
Nice.
And the kids are not old enough yet. The daughter-in-law, they all got antibody testing that was available through the Air National Guard. She tested positive for antibodies. The rest of the family did not. So we don't know exactly when she had COVID, or they were exposed to several families. I mean, they've been in quarantine several times, but never symptomatic. So anyway, bottom line, my daughter-in-law feels she doesn't need the vaccine because she has antibodies.
Yeah. This is so common and an awesome question. And it's actually good because there's great data that we now have that shows that having been infected before does not give you nearly the level of immunity that being vaccinated does. And the most specific and recent evidence that I have that I think you're welcome to share with her if you want to, is that what they did when they're looking at these new variants is they took what's called convalescent serum. So they took plasma from people who had already been infected, but not vaccinated. And then they compared that to serum from people who had been vaccinated. And the question they asked was, how well does this serum neutralize or stop both the wild type SARS-2 virus and all of the variants that are circulating around the globe right now? And what they found was that the vaccine serum worked extremely well against SARS-2, and then only suffered a little bit with some of the variants, but was still in the range they would consider to be protected. On the other hand, for people who had been infected, those numbers were both lower across the board and dropped below the level that they think is necessary for protection for several of the variants. So it's really good evidence that like when you have COVID infection, I think about it as you're like throwing a dart at a dartboard. You don't know where you've landed, but getting a vaccine is like placing the dart into the bullseye. And so it's just like not, I wouldn't trust like throwing the dart from across the room, especially if you can't see the dartboard, over being able to guarantee essentially protection against not only the current variant, but also all the other global variants. So I think I would hopefully try to take that back to her and see if it helps her think about like what the risk is, given that she's already has her antibodies, but knowing that they're not as good as the antibodies that she could get from getting the vaccine.
Thank you. Thank you. That helps.
Yeah, no problem. Other questions?
This is Kathy. I'm not going to turn my video on right now, but thank you for the presentation. I was really interested to hear, like, you know, the overall methods that were used to create these, because, you know, you hear the name of it, but if you don't see, you know, what it all involves, it remains kind of mysterious. Yeah. I just got my second shot on Saturday and I was down for the count for most of the day Sunday, but now I'm good, you know? So that's, I feel, you know, I'm on the way, 2 more weeks. But, you know, the fact that the mRNA vaccine, you know, it's only in your body for a couple of days. and then it's flushed out. Like, so is the mRNA delicate and that's why it doesn't last, or like, how does that work?
Good question. So the mRNA is similar enough to the normal mRNA that exists in your cells that it's degraded by the same machinery that degrades all of your mRNA. So generally the ways your cells make proteins are like, make the mRNA that encodes each protein, then that mRNA gets turned into the protein, but it's not consumed in the process. So it's just like hanging out, having been read into protein, but that molecule is still there. So what you could imagine is through the lifetime of you and your cells, if there was no way to degrade those mRNAs that were everywhere, your cells would just eventually like fill with mRNA and die because there's not enough space for other things. So what your body has already is this lovely system for taking mRNA that's been hanging around for a while and just chopping it up into little pieces and then recycling the pieces and using them for other things. And recycling them into like very, very small pieces. So I'm talking like atoms and small molecules. So that's exactly what happens with the mRNA that's coming from the COVID vaccines, is it gets inside your cell, it's read off into spike protein, and then the same machinery that's responsible for degrading and recycling all of the other mRNAs, there's no way for them to tell that it's like a special mRNA that got delivered through the vaccine. To them, it's just another, piece of trash that they need to take care of and throw away. And that timeline is about 24 to 48 hours, which is why the mRNA gets degraded so fast. And then the other thing, just to add that I didn't include before, is that the protein, the spike protein, is also recycled and degraded along a similar timeline and for similar reasons. So your cells are always making lots of surface proteins, and they don't want those proteins to be on the surface forever. Oftentimes, they only want proteins to be on the surface for a short amount of time, or they want to take old copies of something and replace it with a new copy. So even the spike protein that's a result of the mRNA is only around for about 3 days. And that's long enough for your immune system to learn what it looks like, but then it gets degraded and chopped up and thrown away, the same way that the mRNA is thrown away. And this is by like natural proteases, which are things that chop up and destroy proteins that are already around in your cell. So it's nice because you're able to take advantage of the recycling and degradation systems that already exist to get rid of those things. So I hope that helps.
Yeah, and the other comment I was going to make is that it would be great if this could be even more simplified and made into a puppet show.
Oh, I wish I had more time because that sounds like it would be amazingly fun for me. But yeah, I mean, there's a definite need to get the information out to more people because people are very empowered once they know how things work, and then they can teach other people and they can like reason through things with a little bit more of a background. So yeah, maybe in my next life I can work on that. Oh, I see a question from Heidi, which says, is there a possibility that spike protein from the vaccine could cause a false positive COVID test? Great question. So usually no. So the most often the ways that you're getting tested for COVID are either something called an antigen test, which is looking for spike, and the levels of spike that you're getting from the vaccine are not usually as high as the levels that you'll need to show up positive on an antigen test, or it's a PCR based test. And the targets that they're looking for with that PCR, which is a way to amplify the genetic material of the virus, are not included. It's not spike, and you need to read it off DNA. So you're not going to get a false or you're extremely unlikely to get a false positive from an antigen test. It's impossible to get a false positive PCR test. But something that people are getting tested more and more is that whether you have antibodies to spike or not. And so you're totally right, because if you have the vaccine, you should have antibodies against spike. That's evidence that the vaccine has worked. But if you had a natural infection, you should also have antibodies against spike. So when you're thinking about getting an antibody test, if you want to be able to discern whether you had natural COVID infection or the vaccine, you need to have an antibody test against a different protein that's not spike. So there are other antibody tests that exist out there called that are reactive to something called N protein. So if you're interested in seeing if you've had natural infection, you need to make sure that you're getting an antibody test for this other protein called N protein. Otherwise, it's going to show up as positive, whether you got infected or you were vaccinated. So that's a really good question.
You know, one of the things that I think a lot of people have been thinking about and dealing with is, and it's come up somewhat here, is talking with people who have absorbed misinformation, and coming at this from the perspective of a behavioral health psychologist, which has been my career. One of the things that I learned in really just this last week is that there have been, not surprisingly, in conjunction with the development and distribution of the vaccines, some tremendous efforts that have been, multi-center, involving hundreds of people in medicine, public health, biochemistry and the sciences, and also in sociology, psychology, behavioral economics, all of these fields that look at how does the science get translated. And I was just going to comment that two things that really struck me in looking at those data, the behavioral science that, around this hard science, is one is that there's some really interesting information, and I can share these references if people are interested in looking at this more closely. Very interesting discussions of some of the similarities and differences between people who are vaccine hesitant with regard to the COVID vaccination, as compared with people who are hesitant about, kind of getting a flu shot. And part of that is that there was so much deliberate misinformation, so much politicization of COVID and of vaccination around it. Obviously, that is really complicating things. But also, just the rapidity and the development of the vaccine. So being able to have this really solid information about how the vaccines work is one of the things that is just super helpful and in boosting confidence and boosting understanding of being able to go out and talk with other people. The other thing about it is that there has been so much kind of shaming and blaming of people who are not wearing masks, not taking appropriate public health precautions. And, honestly, I kind of struggle with that, because I think I am acquainted with folks who have died. I'm acquainted with so many people in healthcare who have put their lives at risk, literally, to treat this. So it's really hard to be able to kind of have those curious, open kinds of conversations with people. But the thing that I ran across that I found the most helpful in sort of helping me to do that with the people that I know who are kind of waffling rather than wholeheartedly embracing this vaccine as the thing that we've all been waiting for, is to come back to what you said, Maria, about being able to really emphasize the positive and share those emotionally powerful personal stories, both about the danger and the risk of COVID as causing illness and death, and also about the vaccines as being effective and allowing us all to re-enter into those activities safely, that we've all been waiting for. So to be able to normalize that has been so powerful. The two things that I've seen in the literature that are like, don't do this. One is to repeat or try to contradict the misinformation. So to quote all of the misinformation, COVID's going to do X, Y, Z, or the COVID vaccines are going to do X, Y, Z bad things to you. But that's not true, right? So generally, you kind of don't want to repeat those things, even in the interest of contradicting them, because people will hear you say it and they won't hear that you're contradicting it, right? So that was one. The other is, of course, that it is just not effective to shame and blame people. It actually often will backlash and have them more entrenched to like not get vaccinated. And I think the third that I find really powerful is this idea of thinking about concerns about vaccination as a spectrum rather than an either or. Like somebody might say, oh, I'm not going to do that. I think that's BS. It's overblown, whatever their thing is. But really, the vast majority of people really are influenced by what their friends do and what people they trust do. Maybe they don't trust doctors. They darn well don't trust the government, but they might trust their best friend, or they might trust a clergy person. So being able to identify who they trust and then kind of have those people talking about this. And the other thing is really, if, once we do get vaccinated, being able to post that, normalize it. So make it like, well, what? Really? I mean, this is what we've all been waiting for. Everyone is getting vaccinated. And that becomes kind of the behavioral norm. So we create herd psychology in order to achieve herd immunity. So I don't know. So this is what I've been learning as a psychologist approaching this. And I don't know, Maria, if there's anything from, that you'd want to comment or add to that.
No, I mean, I think that sounds great. And some of it was stuff that I had heard before, but I think some of it, like that it's not super effective to call out specific pieces of misinformation and like debunk them. That's important, because I think a lot of scientists are so evidence-based that like what they feel compelled to do if somebody states an inaccuracy is to just like go all in and like beat that person with facts that say the contrary. But I think it's important to understand that that's probably not going to get us what we want, and that there's like better strategies that we should do instead. So that was very helpful to hear.
Being able to sort of understand that things are on a spectrum. I think I started to say, and then I interrupted myself, that it's just like when we worked on the marriage amendment, just like when we're working on, fighting gun violence, whatever it is, people are not in buckets. It's not, we don't work like a light switch, like you're either this or you're there, right? And so when we're talking to people, I think that's the other thing to share with our friends, right? That like, don't pigeonhole folks. That is not how human brains work. It works on like a dimension or a spectrum. So if we want to label folks as anti-vaxxers, there are a very small number who are just like, vaccines are bad, and those folks you probably are not going to persuade, and it's probably not even worth trying, frankly. It's probably a waste of your time. But they're a small minority, and what we're really looking at is this spectrum from people who are super pro-vaccine, people who are like, well, okay, I guess I have to, people who are vaccine hesitant, and the vast majority are in that vaccine hesitant kind of phase where just a little bit more positive stories, positive information can really, tip them towards acting on information that they feel like they can really trust, and it's really a small number who are way out on the far end of that spectrum. Anyway, I'm sorry, Sarah, I think you. you?
I just wanted to say thanks a lot. Actually, I'm relieved that we don't have to explain a lot of medical stuff, that just telling our personal stories. And I'll just tell you one. I take piano lessons, which have been on Zoom the whole time. And then our piano teacher decided to have a recital in someone's home. And because we're all vaccinated, and it was so nice. It was just like 6 of us and then our teacher. And I really enjoyed it. And then hearing the music live, there's nothing like that. So my latest personal story, besides seeing our grandchildren, which we did see anyway, but not around Thanksgiving and Christmas. But okay, well, thanks so much and good luck.
Thank you.
I just want to say, does it help to say, like, when you meet somebody who doesn't want the vaccine, what I've been saying lately is, well, I'm super glad my folks had me get the polio vaccine. And I'm really happy my kids never had to have chicken pox. You know, when I was a kid, we all suffered with chicken pox, and my kids never had to experience that or the danger of rise. I mean, we had, my friend's daughter died of rise when she was 4. You know, this, Maria, when we didn't know it was bad to give aspirin to little kids, and after rise, and that was a direct, I don't know if you know any of that back history because you're very young, but I mean, sort of young, but anyway. But
you can say very young. I don't mind.
I do think role modeling is great. Our 71-year-old brother-in-law has been living with us for 3 weeks, no vaccines. He arrived and he looked at his brother and said, "Are you vaxxed?" And my husband said, "Sure." And he said, "Well, then, okay." And I said, "I'd like to make an appointment for you." And he said, "Sure, okay. When are you thinking?" I said, "Tomorrow morning at 8:20 at Walgreens." And he did, he went. So this week is his second vaccine. And you know, he hasn't had a shingles shot or a pneumonia shot. So I think it's role modeling, and my husband, who's 2 years older, really has tipped the stage here. So anyway.
That's awesome. Well done.
Very good.
It's been so exciting to see the incredible kind of synergy, or there's a huge behavioral trial that's being run by the Wharton School in Pennsylvania in conjunction with University of Pennsylvania Medical School, and a bunch of behavioral scientists from like around the world. And they are running clinical trials to look at what kind of messaging really will boost people to go get their vaccines. As with so much else of this, one of the things that's super exciting is that that's going to impact every new thing. I mean, it'll impact people going for, you know, pneumonia and flu, just as you're saying with your husband, Therese. I think being able to think about how to communicate public health information in ways that really spark behavior change and don't spark backlash. And so one more thing that I learned from reading that trial, and they've had a couple of things come out. Their most effective message was to have medical clinics or, you know, state-run vaccination programs be able to send messages to people that said, there was 2 SMS text messages. So they would message people's phones, right? And the first one said, your vaccine is waiting. And the second message said, we have a vaccination appointment reserved for you. And apparently that messaging boosted the actual compliance with getting vaccinated by 11% over the traditional, you know, call us if you want to be vaccinated kind of messaging that you normally get. And you're never sure exactly why that worked so well, but that, I mean, that's a tremendous boost for any kind of public health measure. And what they think the difference was is that people first of all felt individually identified and special. They felt like someone was like looking out for their own personal individual health.
Right.
And they also felt like if they didn't get vaccinated, they were going to be missing out on something important, right? So it's so interesting because when I think about the messages that I got from the state of Minnesota, when my vaccine appointments were made, I had the opportunity to get a vaccine appointment, right? It was a contest. I was so fortunate as a healthcare provider, I got in early. And then my husband, as someone over 65, got in pretty early. It became a competition and a prize. You wanted to get vaccinated as soon as you could, right? And then your friends were watching on Facebook to see, did you get your shot yet? And did you have your sticker? And it was the message that I got from the state of Minnesota was exactly that. It was, your vaccination appointment is reserved. Your shot is waiting for you. Come and get it. So, and it's such an interesting process. That model of communication is not anything I've ever seen. And it's exciting to think that more people might go get, once we're through COVID, more people might go get, I don't know, their shots for, herpes or hepatitis or flu or whatever it is.
Yeah, I love that. I think what I really like too is that it's not resource intensive to change your messaging. Like to change your messaging, like it's a public health intervention that costs $0 and increases uptake by 11%. Like what? So I really, I just think that that's exactly the kind of research we need to be doing.
It's amazing.
I think Heidi, you have a question, which is, what can I say to get more pregnant women vaccinated?
Yeah. There's some really, okay, sorry. Just that pregnant women getting COVID it's a horrible situation. And I really would like to help encourage more pregnant women to get the vaccine. And I know they're scared, but.
Yeah, I think, well, I don't know, because I was going to say like the evidence shows, but I guess as we know now from behavioral psychology, it's not necessarily all about the evidence. But I will say that like, I think there's an important difference in where we are now with our understanding of how these vaccines work in pregnant people versus when my pregnant healthcare provider friends were getting the vaccine in January. Like they were really getting a vaccine that we didn't know if it would be safe in pregnancy. And they were doing it because they felt like they knew that COVID was dangerous. So it made sense. But now there's sort of a universal understanding that it will not threaten the pregnancy, that it will not threaten the child. And I think that's good. And that's something that I think everyone should know, because I'm worried that some people may have heard that initial message of like, hey, pregnant people, like, don't run and get your vaccine because like, we don't know what the heck is happening. And it never got replaced with an updated message, which is like the overwhelming majority of evidence suggests that these are safe for you.
Right. But still, there are providers who are allowing pregnant women to make their own decision, whatever you think is best.
Yeah.
And I have seen where I work, there are pregnant women who are they have to deliver the babies early because the woman is dying or is so sick.
Right.
And it's really heartbreaking. And I just, but I know what you're saying, Yeah. And
I think physician education is also incredibly important because it's such a fine line. Like technically, I think a lot of people are on the cautious end because the EUA like doesn't specifically include pregnant people. So like a lot of physicians are being reminded that like, you need to use specific language because it's a slightly different population. But I think that there are ways to effectively advocate for your patients that do not include like letting people sort of make a decision in a vacuum of knowledge. Like, yeah, that makes me really, really sad. And I think that's where providers just need to be better educated so that they know like how to present the best evidence, how to present the sort of personal reasons for doing it, especially because as a provider, you can say like, I've seen, people, pregnant women like die from COVID or have to have their delivery induced. And then the child is like either, like in a really rough shape or doesn't end up surviving. And like all those things are real and can be prevented. So I think that's probably something to maybe add to the mix is like sharing what you've seen happen negatively and positively.
Right. And Maria, very simply, because that's all how I understand it, pregnant women, your immune system, okay, you don't want to reject the baby.
Right.
So a pregnant woman is probably at greater risk when she contracts COVID because there's changes within her immune system that.
Yeah, the weird thing is I haven't looked at this data like extremely recently. I probably last looked like 3 months ago. And actually the outcomes for pregnant people like weren't significantly worse than for the general population.
Okay. Just what I see.
But I don't know if that like that was early data. So I think first of all, I would look at that data and I wouldn't be surprised because pregnant women get hit so hard with other infectious diseases like flu, massive threat to pregnant women, more like above and beyond the general population. So I guess I don't have updated data for you, but there's lots of inherent risks of pregnancy or like being hypercoagulable as somebody who's pregnant and then also having COVID. Like your risks for clots are going to go through the roof. Yeah, it's and you protect your baby. Like there's been a good amount of studies showing that like the antibodies from the vaccine are transferred through the placenta and then the baby is immune. And so your baby's not going to get COVID for the first, X weeks, months of its life. Like that's so cool. That'd be very motivating to me to be like free immunity for your kid. Yeah. So good luck though with those conversations.
Yeah. Thank you.
We're coming to the end of our scheduled time and I'm so grateful for, superb questions, superb presenting. I could go on asking you questions all night, Maria, probably. One thing that I am going to ask, if you happen to have a good reference, or if you've run across any kind of, like a video or podcast or anything like that, is that we don't have really time to get into tonight, but I think is critically important, are some of the kind of sociodemographic differences in how COVID is impacting different communities, and particularly BIPOC communities being so much harder hit. And at the same time, we're hearing that there is more vaccine hesitancy, part of which understandably is acknowledging, the history of mistreatment and exploitation and mistrust of the medical community, particularly in some parts of the Black community. And I've seen a couple, I think one of the things that I would like to do with MUUSJA'S is to be able to post on our website also there was a forum that I saw the AMA did with several Black physicians and scientists talking about that particular issue. But I'm wondering if you've run across anything along those lines that looks at, sort of culturally congruent messaging or ways of tackling, these issues in of, maybe sort of the kind of messaging or the kind of outreach that might be possible, across race and class, because I remember I saw your slide that said that the actual efficacy of the vaccines and the safety of the vaccines does not differ, right?
Yeah. I think in terms of resources, I don't have anything that, like, most of my learning on that is from a podcast that I listen to for like 5 hours a week that's very in the weeds. So I'm not sure that it's a good general resource. One thing that might be worth looking into is that Stanford Medicine has been releasing a lot of short videos of physicians from different identities describing why they got vaccinated. And I think those are probably available through the main like Stanford Healthcare website. And they've had people from, all different ages, races, classes. And I think that has been pretty effective in terms of getting Stanford compliance up. The interesting thing I will say about the vaccine hesitancy concerns in minority communities is that the latest data I've seen is that it's actually not true. So like the narrative that came out early was like, we need to be messaging this to Black Americans because they're more hesitant about the vaccine, which makes sense because medical racism, of course. And then actually, they're not more hesitant. Like the most hesitant population is white male Republicans. So like, it's this fine line where, of course, you want to provide outreach to these communities because they are suffering more due to, structural racism and structural inequalities. But at the same time, they're actually not more hesitant than other groups. And specifically, the most intractable group might not be the people who are getting the most outreach, which are, these like middle-aged to older white men with conservative values. So that was something really interesting that I recently became aware of. Yeah, so just something to keep in mind.
That's very interesting.
Yeah.
I mean, think about particularly, kind of the preponderance of the greater Minnesota population, that kind of thing, really thinking about who is out there not getting vaccinated. So Therese, tell your husband to keep up the good work. I think that's, because people do have more trust and more faith in someone, who looks like them, maybe, and is kind of their same age and gender. Oftentimes, those are the best models. So,
yeah. Well, Karen, I know a number of nurses at my hospital who are vaccinating, and a couple of them are Somali American nurses. And so they're going into their community more. And I work with the Bloomington Public Health Department and do vaccines. And they have made a really strong effort to reach groups that don't work 9 to 5, that aren't working from home, people in restaurants and food processing plants and all these groups. So this is really, which is wonderful to see. And we're going to try to even get out into more communities that where transportation is an issue and things like that. So people want the vaccine, but they're just struggling to make the 2 appointments and get to the appointment, that kind of thing. So that's what we're working on.
That's marvelous. I know there is, so the State Action Network in the state of, I think it was North Carolina, the Unitarian Universalists, the MUUSJA equivalent for that state, created actually a phone bank, and they teamed up with the state public health agency, and we're actually actively mobilizing church members to phone bank and call people and give them information about where and how they were able to get vaccinated. I don't, we may have a good enough system in Minnesota that would be kind of redundant or not necessary. I don't know, but it was, it was certainly an interesting idea, and that's, it's something that MUUSJA could do if it looks like there would be a need for it. So, well, we are running over time, and I thank you all for your patience. And Maria, thank you so much. It's just wonderful to have you here.
This has been a
So-
pleasure. I really appreciate the opportunity and wish you all the very, very best in convincing people and in staying safe and healthy and seeing the light at the end of the tunnel.
Right.
You too.
With that, I will extinguish our chalice and my sign language chalice. But keep the light of truth in our heart until we meet again.
Thank you.
Good night,
Bye.
all.
Good night.
Good night. Thank you.